Good afternoon, everyone. I realise I'm keeping you from your lunch, so I'll keep this moving along. So thank you to the IIC for this opportunity to present, and we're going to talk about getting started with IoT. What are the pitfalls, what are the difficulties in getting going in an existing, if you own an existing factory. So we saw a little bit earlier from Jim's presentation that what we call the Brownfield opportunity is huge within this market, but it is also incredibly conservative. And the customer I'm going to talk to you about in a minute fit into that mold very, very clearly. There's also a number of other initiatives around the marketplace, one of which is called digital manufacturing on a shoestring. And that one is quite new. It's between Nottingham and Cambridge University sponsoring it. But it is also of a similar theme to what I'm going to talk about today. So Corlina is a software company. We're based in California. I'm one of 4 founders. I'm the only one who lives in a sensible place like London. And we're very much a startup. So our premise is we create an environment where the devices are secured, they can't be tampered with, and the data becomes reliable from those devices. And these are edge compute devices. So somebody might plug in a USB drive to one of these edge compute devices, and we will tell you what has happened. So the other thing that's important about our software is that we're very much looking at the here and now. We're not analyzing your sensor data over a 3-month, 6-month, or 9-month period. We're telling you what is going on with your data now. So is my valve still working? Is the pump still pumping? Is the motor drive too hot, or is it vibrating too much? And we tell you these things now, not about the past. Ours is entirely a software solution. We don't sell any hardware. We work on most of the major flavors of Linux. So this customer of ours is based in Chicago, and they are in the super glamorous business of making closures for items. Now, sometimes these may be seen as just bottle tops, but if you think about your medicine cabinet and the kind of closures that go on aspirin, the kind of closures that go on any sort of medicine, whether it be simple cough mixture, these have a little bit more technology attached to them. You have to push them down and turn them, and they're supposedly child safe. So that's the kind of thing that this customer is making. They thought, and still think a little bit, that IoT is too expensive for them. They told me early on in this engagement that, do we need to build a new factory to get IoT? How do we do this? And they actually coined the term, how do we get the magic of IoT without all the money going out the door? Because this is not a high margin business. So they have to be able to manage their cash flow very, very closely, and they would not have spent a lot of money on IoT up front without knowing what the results would be. They also have very, very large injection molding machines, and they are between $500,000 and $1 million each. They are all full of sensors, but none of that information is made available to them. That's all for the manufacturer of that machine to keep it healthy and to measure its performance. It is not shared with the direct manufacturer. Also, the other point on that last slide is that the injection molding production line consists of pumps, valves, motors, and many other different items. And any one of those failing can be catastrophic to that production line and cause that what they call ancillary equipment. If any of that fails, then the production line will stop. So to give you a flavour of how big this company is, they have 6 production lines in each factory, and each one has an injection moulding press. They're producing 3,000 of these closures an hour on the smallest production line, and each one of those production lines has this auxiliary equipment, and we've put it down as 3, and it may be the rollers on a conveyor, it may be the motors that are driving the conveyor, it may be water processing. And I mentioned this water processing. There's lots of regulation about the temperature of water you can expel from your factory. There was an article a few years ago about a company that was expelling hot water into a local river and killing the ecosystem of that river. So this now needs to be monitored by their local government body that says, here's your license to operate a factory in our town. So you must look at this, and it's not only for the safety of the machine. There are situations where if the internal temperature of the water that is cooling the injection moulding press becomes too high, then the closures are not made to the right tolerance and will not work. So then you've wasted your whole production cycle. So you can see how rather mundane sensors and measurement might really be quite important. So what did we do with this company? And I'll declare that they were known to us when we set our business up, and they were helpful and friendly. But also they're a reasonable sized company, and they shared with us the sort of things they were worried about in getting started with IoT. So we said, well, we can help you, and we should focus on just one production line. And how do we measure the systems that are important to you? So what is it that production line is doing, and what is it that causes you problems? So unplanned outages certainly was their biggest issue. Not knowing when issues were starting to happen. So was that motor vibrating more than it should? And actually, how do we know how much it's supposed to vibrate? How do we measure that kind of information and then make some decisions based on it going out of tolerance? So we focus very much on off-the-shelf equipment and the existing auxiliary systems that they have in place. So what does the system output? So, as I said earlier, we focus on the here and now, last 24 hours of activity. So as we look across at the charts, we have chilled water temperature, and as we talked a little bit about before, this is quite important for the health of the injection moulding press. And we can see it's reasonably constant, and the tolerance is set 16.5 degrees. If that starts to go hotter, then we would set up an alert with them to say, this is outside of the tolerances that you've set. The other measures are to do with the pump motor, and that's temperature and vibration. And the two parts, of course, to vibration, accelerometer, and if I could read my notes, I'd tell you the other one, velocity. So we measure both of those two things with a single sensor. So as you can see, this is a reasonably simple setup. The graphs are driven from an InfluxDB database that is on site, and it's at a small level today, but is very scalable to be much larger. So the schematic of what we've built, and I said we used off-the-shelf systems, so these vibration and temperature sensors are readily available from probably people at this show. The system called the IO-Link Master is effectively an analog to IP converter. So we take an Ethernet feed from that device, and that device can take up to 8 different sensors, and you can have multiple IO-Link masters depending on the size of your production line. We take that information into our edge compute device, and this is an edge compute device running Linux. We don't really mind which one. In this particular instance, it's an Advantech gateway. But you're not really bound by this being inside the factory, because that Ethernet connection could be 100 meters away. So again, you could separate, and this is a relatively unclean environment in this factory. So it has to be industrial strength equipment to maintain its integrity. This schematic and how to put this together, we call a blueprint, and that's available on our website. You could take this as a system integrator or as a potential end user and build this yourself. Our system is available as a download, as the agent, and then as a free trial for the cloud-based. But again, this is very much an on-premise solution with cloud control of security and data reliability and general health of devices and sensors. So you're not pushing your sensor data to the cloud. You're just keeping it on site in a database, which, as I said earlier, we use an influx database that is, depending on your size, is free. What about the money? I said this was cheap and low risk. So hardware components, including the gateway, for this single production line were under $3,000. Implementation, which the most expensive part of it was putting the cabling on the production line. Now, with wireless technology, Bluetooth, maybe that can be reduced dramatically. The type of sensors were all hardwired. So of that 10,000, over half was spent cabling locally. And again, that introduced for us a little bit of a delay to make sure that it was done correctly and to the right specification for the factory, not necessarily for our equipment to work properly. So a week's downtime of one production line would cost them $20,000. And that doesn't factor into account they may be late in delivering to their end customer, that they may have to move production around to another site. They have 8 different factories and around 45 different production lines, and there are some duplicates. And they even went to the trouble of actually having spare production capacity at all times because of potential failure. Again, not factored into the cost there. If one of the injection molding presses was damaged, then that is a very, very expensive piece of equipment. So we've estimated a replacement would be around $500,000. Now, in a business that is only making single-digit profit margin, that's an awful lot of money to find. So we've designed this, and as I said, the blueprint's up on our internet site. You can start very small. You can see results. You can maybe feel the magic of IoT on a single production line. And actually, it may not be for every factory, but it might be. It might really save the day on planned maintenance. It might produce some great ideas about improving productivity. But you may not need to spend hundreds of thousands of dollars to find that out. Our product scales to thousands of sensors and edge compute devices. Everything we put together was off the shelf. And there are many different manufacturers of sensors and industrial computers that could fulfill this need. And we would urge anyone who is an integrator to say, can we build on this idea? Can we put our own stamp on it? Can we take our knowledge of analytics and use this to drive the data into our analytics engines and find a way to actually introduce IoT to more companies more quickly? Does anyone have any questions?